Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic aromatic substitution, EAS, is a well-established reaction mechanism in which an electrophile replaces a hydrogen atom on an aromatic ring. Step 1 Mechanism Overview. In EAS, the electrophile, E+, attacks the pi electron cloud of the aromatic ring to form an intermediate. This intermediate is a carbocation in which the electrophile is covalently bonded sigma bond to one carbon of the ring, disrupting aromaticity. Step 2 Identity of the intermediate. This intermediate is called a sigma complex, also known as an arenium ion or valent intermediate. It is a cyclohexadienyl cation where the electrophile is attached via a sigma bond and the positive charge is delocalized over the remaining carbons of the ring. Step 3 Completion of the reaction. In the second step, a base, often the conjugate base of the acid catalyst, removes a proton from the sp3 carbon bearing the electrophile, restoring aromaticity and yielding the substituted aromatic product. Step 4 Why other options fail. A. Free radical. Free radical intermediates are involved in radical substitution reactions, not EAS. C. Benzene intermediates arise in elimination addition mechanisms typical of nucleophilic aromatic substitution under very harsh conditions, not EAS. D. Carbenes are neutral species with a divalent carbon and are intermediates in reactions such as cyclopropanation, not EAS. Therefore, the correct answer is B. Therefore, the correct answer is option B.